In this figure, we're going to talk a little bit about protein-substrate interactions. And it's first important to note that all proteins are adapted to interact with some other substrate. In some cases, they are protein-protein interactions, but in many cases, it's a protein interacting with some substrate, such as a nutrient or an ion or other substrate. Now, what we're going to use as our example is an enzyme over here, and that's our hashed blue molecule. And what we note is that that molecule has to have a very particular conformation or shape, such that it has a binding site, a region to which it will bind with, very specifically, a particular substrate. Now, so we have to have some stability in the protein structure, some consistency in the protein structure, such that that active site is maintained. Now, our substrate will bind to that particular adaptive site on the protein, the enzyme in this case. And when it does so through what's called an induced fit model. In other words, both molecules will be modified slightly in their structure to get this particular bonding to occur. That's usually some weak bond interactions that allow this substrate enzyme interaction to occur. Now, then we end up with this state where the substrate molecule is held in a particular position by our enzymes, called the enzyme-substrate complex, such that the reaction that we're having occur, let's assume this is a hydrolysis, where water is going to come down and interact with this particular substrate and break the bond here between these two portions of our substrate. Well, that reaction could occur, out here in the solution as well, but it's very unlikely given the amount of thermal energy in the system. In other words, the water molecules are not likely to hit this bond and interact with this substrate to cause that reaction to occur at a high rate. What our enzyme allows is holding of this substrate in a very particular position for that water to interact with this bond site between the portions of our substrate, causing our reaction to occur with much increased frequency. What we've done is we've reduced the activation energy. And so we get this sort of a conformational change, a shifting of our enzyme structure. We get our interaction, increased interaction with water in this scenario we're providing here, with that bond between the two portions of our substrate, and the bond is broken. And then our enzyme will release our broken substrate in this case and return to its original position, and we can start this cycle all over again. In many cases, in terms of an enzyme-substrate reaction, this can occur thousands of times per second.